Imagine for a moment that our civilization has vanished. 10,000 years have passed. 100,000. A million. All our cities have turned to dust. All our books, servers, and hard drives have long decayed, breaking down into basic elements. What will remain of us? What evidence of our existence will a hypothetical future civilization discover amid the ruins of our world? This question is not merely a philosophical exercise. It is a fundamental technological challenge. We live in an era known as the information age, yet paradoxically, our information is the most fragile in history. The great library of Alexandria burned, and we lost priceless knowledge. Today, we risk entering a digital dark age, not through fire, but through the simple degradation of storage media. Hard drives? The magnetic layer degrades in 5 to 10 years. Solid-state drives? They lose charge from memory cells over decades. Even archival optical disks, like M-Disk, designed for 1,000 years, seem like child's play on geological timescales. We accumulate petabytes of data about our science, culture, and history, but we record them, in essence, on water. But what if humanity could break free from this cycle? What if we could create a storage medium so durable that it outlives planet Earth itself? What if humanity leaves its ultimate digital DNA imprint for future civilizations? Today, we discuss a technology that turns this dream into reality. Crystalline Memory, storage media capable of preserving humanity's legacy for billions of years. 1. Crystal immortality. Through the efforts of scientists, including those from the Optoelectronics Research Center at the University of Southampton, a technology has emerged that sounds like science fiction: 5D optical data storage. Forget magnetic tapes or electrical charges. The new medium is one of the most abundant and stable materials in the universe: quartz glass, or silicon dioxide. Why quartz? Because it is virtually eternal. It is chemically inert. It fears neither water nor radiation, and most importantly, it withstands extreme temperatures. Data recorded in quartz can endure heating up to 1,000 degrees Celsius. But how can one record anything in a solid piece of glass? The answer lies in the realm of femtosecond lasers. These are lasers that emit pulses lasting 1/quadrillionth of a second. Such an ultra-short and ultra-powerful pulse does not destroy the glass, but it alters its structure at the nanoscale level. Imagine the laser as an ultra-fine needle that embroiders information within the three-dimensional volume of the crystal. But why is the technology called 5D? A standard compact disc is a 2D medium. Data is recorded on a flat surface as pits and lands. 5D technology goes incomparably further. The laser creates nanostructures inside the quartz, known as nanogratings. Information is encoded in 5 dimensions: 3 spatial coordinates, x, y, z, that is, the precise position of the nanograting within the three-dimensional glass. The 4th dimension, orientation, the angle at which this nanostructure is positioned. The 5th dimension, retardance, how the structure slows down light passing through it, a magnitude known as birefringence. By combining these 5 parameters, scientists can record immense volumes of information. A single disk the size of a standard CD, created with this technology, could potentially hold 360 terabytes of data. That is the entire Wikipedia multiplied by 1,000. But even 360 terabytes is not the primary advantage. The key is durability. Thanks to the extraordinary stability of quartz and its nanostructures, the estimated storage lifespan of this data is 13.8 billion years. Consider that number. Not millions, billions. The age of our planet, Earth, is 4.5 billion years. The age of the universe since the Big Bang is 13.8 billion years. We have created a technology capable of storing information for the entire duration of our universe's existence. A disk recorded today will outlive the sun. It will survive the death of the solar system and perhaps even the Milky Way. This is memory that is literally immortal. 2. Digital DNA of civilization. This technology takes us beyond mere backup. It opens doors to projects bordering on metaphysics. We can create black boxes for humanity. Such initiatives already exist. The Arch Mission Foundation aims to create backups of human knowledge and distribute them across the solar system. They have already sent a library to the moon aboard the Israeli spacecraft Bereshit. Although the craft crashed, the quartz disk with the data most likely survived on the surface. Imagine a cosmic archive. We could launch millions of such quartz media into interstellar space. This would be our message in a bottle sent into the cosmic ocean, a message to other civilizations or those who come after us. We can permanently preserve every scientific treatise, every symphony, the full human genome, all our literature and art, from the Epic of Gilgamesh to quantum field theory. This is our digital DNA imprint. But here arises a new, even deeper problem: the Rosetta Stone issue. When archaeologists discovered the Rosetta Stone, they could decipher Egyptian hieroglyphics only because the stone featured a parallel text in Greek, a language they knew. Now, imagine that in a million years, someone finds our 5D quartz disk. First, how will they guess that this piece of glass contains information at all? Second, how will they read it? It requires a specific device, a polarization microscope. Third, even if they read the binary code, how will they decode it? How will they understand file formats, languages, context? Creating an immortal medium is only half the battle. The other, perhaps more complex half, is creating a universal key to these data. 3. The burden of eternity. Crystal memory technology poses not only technical, but also ethical questions. If we create an archive designed for billions of years, who will decide what to include? What version of humanity do we want to present to eternity? Do we archive only our finest achievements, science, art, philosophy? Or should we honestly include our dark side, our wars, our cruelty, our mistakes? If a future civilization finds only a filtered, clean version of our history, would that not be the greatest lie? And if they find the full truth, might they not be horrified by who we were? Creating an immortal archive is not just an act of preservation, it is an act of self-definition. It is a choice of how we want to be remembered on cosmological timescales. We stand on the threshold of a new era, an era where we are no longer hostages to fragile media. For the first time in history, we gain a tool to challenge entropy and oblivion. Crystal memory is our chance to leave a mark that time cannot erase, a legacy etched in glass by light traveling through eternity. The question is only what we will write in this final letter to the universe.
Glad to have you here. See you again soon.